Hello, Andreas from Prediktera here. In this video tutorial, I will teach you how to use Evince to do quantification analysis of image data using PLS. The example we will look at here is hyperspectral images of plastic bags containing a mixture of 3 different types of powders. First, we will identify objects in the image, which are our 7 samples, and then use the average spectra for each sample, together with a percentage of each powder type for each sample as our calibration dataset to train the PLS model. Finally, we will apply this model to analyze a new sample with unknown content. After removing the background pixels, the image looks like this. Right-click on the contour plot of the image and select Analysis and Object Identification. Set the mean area to 5,000 pixels. This means that any object under 5,000 pixels will not be included, which can be useful to remove small unwanted objects. In the data tree, you will have a new data set based on the object identification. In the table area, you can see that the new dataset consists of 7 objects corresponding to the samples in your image. If you go to the new dataset in the data tree and expand it, then find the X training and drag and drop this to the plot area. And then select to generate a spectral plot. This spectral plot is showing us the spectra for each of our objects. In this new object dataset, the data has been reduced to just be the average spectra for each sample, instead of all the pixels in the image. The histogram is showing you the distribution of the area or the size in pixels for each of the objects. In the settings panel, you can look at other spatial parameters, like the longest distance or the roundness. In the quick info, you can get a summary statistics for each of these parameters. Now, let's assign reference values or Y variables to each of the samples. Right-click in the data table and select New Modification, New Variable. Write the name of the variable. In this case, I will call this variable vanilla percentage. The vanilla variable has now been added to my dataset. I will now repeat this step to add additional variables. I have now added my 3 variables: vanilla, baking soda, and potato starch. You can either manually enter the values for these variables, or you can copy the values from a data table, for example from Excel. In the field for the first sample and for the first variable, right-click and paste the values into Evince. Right-click on our object identification dataset. Select New Model and PLS Model. A PLS model for all 3 Y variables will be fitted using cross-validation. A number of default plots for PLS has been generated. The model overview plot is showing you how well your PLS model can explain the Y variables. In this case, the percentage of the 3 different powders using the spectral data for each sample. The automatic cross-validation found 3 valid components. The red bars, R-square, shows the model fit for the training data. The blue bars Q-square is showing the predictive power of the model using cross-validation. The observed versus calculated plot is showing you the calibration curve for our model. Under Statistics in the Settings panel, you can add a linear regression line and regression statistics. In the Settings panel, under Data Range, you can change the variable to look at. Now, let's use this model to analyze the content of a new sample. Right-click on the PLS model in the data tree and Save As. Give your model a name. Go to File and New Project. Select the image that you want to predict. And then go through the import wizard. Let's now clean up the image by removing the background pixels. I will do this using PCA. When you're satisfied with the cleanup of the image, right-click on the contour plot and select Analysis and Object Identification. As we did with the training data, I will set the mean area to 5,000 pixels. We now have a new dataset consisting of the average spectra for the sample. Right-click on the dataset and select Predict Dataset from Model. Now select the PLS model that we had just saved and click on Predict. You can now see the PLS model in the data tree. Expand the PLS model and under External Predictions you will find the predicted dataset. Select the ypred for the last component. This is the predicted values using all three PLS components. Drag this to the table area to see the predicted values for this sample. This sample actually contained a mix of 33% of each material, so the prediction is pretty close. Now that we have the average content, what about the spatial distribution of the three materials in this sample? We can look at this by using our PLS model to predict the percentage of the materials in each pixel. In this example, I will choose to do this analysis for only part of the image. I will use the rectangular selection tool and then select the area I want to analyze in the center of the sample. Right-click on the image and add selected to New Dataset to save this selection as a new dataset. Right-click on this new dataset and select Predict Dataset from Model. I will select my PLS model and click on Predict. A contour plot is now generated that shows the spatial variation of the percentage of the three powders. In the Settings menu, under the Data Range, you can change the variable to look at. The pixels that are red show areas that have a higher percentage of the specific powder, and the areas that are blue have a lower percentage of the specific powder. By selecting an area, we can see the mean, max, and average value in the quick information window.